Hello everybody, this is Mr. Longo here, and in this video we are going to cover our sum and difference formulas. So you should have your note sheet that was provided to you with all of your sum, difference, and even double angle formulas. For this video we're just going to use sum and difference, and we're going to do another video on the double angle formulas. So make sure you have this sheet handy for this lesson. So here we go. We are going to work with the sum and difference of sine, cosine, and tangent. But it is very important for you to remember that we are going to be dealing with exact measurements from the unit circle. Okay, so from the unit circle, if we're in degrees, we need to know how to work with 30, 45, and 60. And of course, reference angles in any other quadrant. The exact same thing is going to take place with radians. We are going to need to know our pi over 6, our pi over 4, and our pi over 3. So this is going to be attached to the unit circle. And what we need to do is think about how can we use the most popular angles in the unit circle to work with the cosine of 15. Now, think about how we can take those angles given and give us 15. If you thought of cosine of 45 degrees minus 30 degrees, you have the exact same thought that I did. However, you could also do 60 minus 45 degrees. That would also give you 15 degrees. So the first thing you need to do is figure out how you can get 15. And from there, we are going to use the formula. So again, from the formula sheet, we have the cosine of 45 minus 30. Now the formula is going to tell us that we are going to take the cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. Okay, that's just the formula. And all we did was substitute in our angles that we chose to use for A and B. Now again, exact answers from the unit circle. So what is the cosine of 45? And the answer to that is the square root of 2 over 2 times, what is the cosine of 30? The answer to that is the square root of 3 over 2 plus, now of course, since that's multiplication, we're going to simplify that together. What is the sine of 45? The sine of 45 is also the square root of 2 over 2 times, what is the sine of 30? The sine of 30 is 1/2. Okay, now what we have to do is simplify this. And yes, we're going to have an ugly answer. Of course, you can use your calculator to assist you, but the square root of 2 times the square root of 3 is going to give us the square root of 6 over 2, of course. Now, your calculator is not going to be able to help you with that in terms of the radical part. Plus, the square root of 2 times 1 is just the square root of 2 over 4. I'm sorry, this is supposed to be 4 as well. So we have the square root of 6 over 4 plus the square root of 2 over 4. Since we have a common denominator, the answer to this question is simply going to be the square root of 6 plus the square root of 2 over 4. Now you cannot add unlike radicals. So yes, we are going to leave it just like this. Okay? So I'm going to give you the opportunity to try the sine of 75 on your own. Now, you can use the formula. You can choose which angles are going to add or subtract to 75 degrees, but basically pause the video and see what you get. Give it a shot. Click play when you're ready. Okay, so I'm guessing what you chose to do was rewrite this as the sine of 30 plus 45. So what we're going to do is use our sum of sines formula, and that's going to give us the sine of 30 times the cosine of 45, and then we are going to add that to the cosine of 30 times the sine of 45. Again, jump back to the unit circle. The sine of 30 is 1/2. The cosine of 45 is the square root of 2 over 2, plus the cosine of 30, we know is the square root of 3 over 2, times the sine of 45 is also the square root of 2 over 2. Now this should look very similar to the problem above, and it's for an actual reason. If we multiply 1 times the square root of 2, we get the square root of 2, and 2 times 2 is 4, plus the square root of 3 times the square root of 2 is the square root of 6 over 4. We have a common denominator, so the answer is, again, the square root of 2 plus the square root of 6 over 4. Now, I want you to pay attention to what just happened there. If you remember, the cosine of 15 and the sine of 75, if you notice the angle measurements, 15 plus 75 is 90. And going all the way back to when we first started talking about trig, or even when you were back in geometry, the sine of an angle is going to be equal to the cosine of its complement. That's why we have the exact same answers here. So that's only going to happen when we're working with complements. That was just thrown in there as a flashback for you. So the next one is the tangent of 11 pi over 12. And tangent has quite a complicated formula to work with. So this one, you might have to work with some old school radical skills as well. But what you need to do is think of two angles that will add up to 11 pi over 12. Now remember, we have pi over 6, pi over 4, and pi over 3. Hint, hint. None of those have a denominator of 12. So how are you going to get this to add up to 11 pi over 12? Well, you should convert those angle measurements in radians to something over 12. Convert pi over 6 to 2 pi over 12. Convert pi over 4 to 3 pi over 12. Okay? Now think about it and give tangent a try. So the tangent you should have come up with, I used 3 pi over 12 plus 8 pi over 12. Now remember, when we add fractions, that's going to give us 11 pi over 12. So I decided to use the tangent of 3 pi over 12, which we know is pi over 4, plus 8 pi over 12 is going to reduce to 2 pi over 3. Now those are the two I'm going to use. Now the formula again is a little bit more complicated, but if you have that, you should be able to work it out. So this one, we have the formula is the tangent of pi over 4 plus the tangent of 2 pi over 3. This is all over 1 minus the tangent of pi over 4 times the tangent of 2 pi over 3. Now again, we are going to need exact values here. So the tangent of pi over 4 is 1. And then we are going to add the tangent of 2 pi over 3, which is a negative square root of 3. This is all over 1 minus the tangent of pi over 4, again, is 1, times a negative square root of 3 for the tangent of 2 pi over 3. And again, now we need to simplify. So the top, all by itself, is 1 minus the square root of 3 over the denominator, which is going to be 1 plus the square root of 3. After we simplify, because 1 times a negative square root of 3 is a negative square root of 3, and minus a negative turns into a plus. Now I want you to go back in time to where we learned about radicals. We are not allowed to leave that in the denominator. So we have to multiply the top and bottom by what we called back in the day the complex conjugate. So the conjugate of 1 plus the square root of 3 is 1 minus the square root of 3. Again, we cannot leave a radical in the denominator. And now all we have to do is multiply. So 1 minus the square root of 3 times 1 minus the square root of 3 is going to end up giving us 4 minus 2 square roots of 3. All over, if we multiply the denominator, of course our radical is going to disappear. So we're going to end up with a negative 2. And since we can factor a 2 out of all of this, we are going to simplify all the way down to a negative 2 plus the square root of 3. Now again, that problem was complicated if you do not remember how to work with radicals. It is crucial that you remember how to work with radicals, okay? So that's it. That one was a little ugly, but it is what it is. That's how we work with tangents. Now the last two examples are very similar, but in this case, we are going to give you an angles in certain quadrants, and then you're going to have to determine what the values of sine and cosine are going to be. Okay, so this is one problem with two parts. So it is given that cosine of A is the square root of 2 over 2, and it is also given that that takes place when sine is negative. So if cosine is positive, that's x, but sine is negative, that's y. We need to go to positive negative land and draw angle A. So we are going to draw angle A down here. And then we need to think about what's going to give us the square root of 2 over 2. Well, cosine is adjacent, so that would be the square root of 2 over 2. And this would be negative square root of 2 over 2. And this, of course, is going to be 1 because that's just a reference angle of 45 degrees, and we're just using the unit circle for this coordinate down here when we have the square root of 2 over 2 comma negative square root of 2 over 2. So that one uses the unit circle. The next part, we have the tangent of B is given as 12 over 5 when sine is positive. So remember, sine is positive on the top two, but tangent is positive in quadrant 1 and 3. So we are going to draw this on quadrant 1. And we're going to stick angle B as our reference angle. So if tangent is given as 12 over 5, opposite over hypotenuse is going to say that this guy is 12 and this guy is 5. Now, to find our hypotenuse, all we need to do is Pythagorean theorem, and we get 13. Okay, so those are our two different triangles with our angle measurements given. So, how do we find the cosine of A plus B? We just need to go use our formulas again. So the cosine of A plus B, the formula is again on that sheet of paper. So what we need to do is just talk about what is the cosine of A, and the cosine of A is given to us, and we have the square root of 2 over 2. And now times, what we need to do is multiply this by the cosine of B. Now the cosine of B is 5 over 13. Okay, so it's 5 over 13. And then of course for the sum of cosines, it's minus. And now what we have to do is use the sine of A times the sine of B. So the sine of A is negative square root of 2 over 2 times the sine of B, which is 12 over 13. Okay? So that's the ugly setup. Again, you have to be able to work with radicals and fractions. So 5 times the square root of 2 is going to give us 5 root 2 over 2 times 13 is going to give us 26. Minus. And now we have to multiply negative 2 times 12, which is a negative 12 root 2 over, again, 26. Now this time you have common radicals. So minus and negative turns into plus. So 5 root 2 plus 12 root 2 can be added to 17 root 2 over 26. And there you have it. So B is on you. All of the setup has already been done. You just have to use your formula for the sine of A minus B. and plug it all in and try to simplify it. Go ahead and pause it, try it on your own, and we'll see what you get. So if you went and said negative square root of 2 over 2 times 5 over 13, and then we should have minus the square root of 2 over 2 times 12 over 13, then you have simplified everything correctly. But this time, you'll notice that this was not over here with a negative. The negatives have switched. So after you simplify, you'll have a negative 5 root 2 over 26 minus 12 root 2 over 26. And this time we end up with a negative 17 root 2 over 26. Okay, and that's it for this video on the sum and difference formulas with trigonometry. This is Longo, and I'm out. See you, bye.